I welcome Madam Shanu. Shanu Solanki. She is a faculty in Computer Science and Engineering Department. She has done BSc Computer Science from Kurukshetra University and ME Computer Science and Engineering from Thapar University, Patiala. She is also pursuing her PhD. Her specializations are in the field of advanced algorithms, semantic web technologies, machine learning, and data mining. She is also coordinating in our institution long term as well as short term problem, and she possesses more than 16 years of teaching and research experience. She will be interacting with you on graphic analysis using R. So, madam,
Thank
please.
you, ma'am. So I welcome all the remote center participants in this session on graphical analysis using R language. You have attended earlier R introduction session and how you can go about using the R interface for analyzing your data graphically. So in this session, you will get an idea about what kind of graphical plots you can go ahead with your data. So when we are going to create a graph that is possessing various properties and using R language commands, you can improve the look and feel of your graphical plot. And for that purpose, R language is providing you with a command that is referred as plot command. And using this command, you can draw a particular graph in R and you can modify its properties using the various arguments. So as you can see that in a plot command, we can have various attributes. For example, you can modify the points that you are going to plot, or using the line which you are plotting, you can specify what kind of color you want to display or what kind of line width you want to opt for, or you can specify the different features of your graph, like modifying the axis of your graph or modifying the values displayed on that, or making certain changes in the title and the subtitle or the legend information. So these kind of all property changes you can done, but the change in R is that as R is a language, so you will have to do all the tasks using a particular command and by modifying its values. So one by one we will see how to go about. Before we proceed with the plot command, you will have to make use of certain data set. So R provides you with many inbuilt data sets and pressure is one of them. So before you go ahead with any particular graphical analysis, you will have to look for its structure. And in R language, we are having a command str for that purpose. Bottom of the slides, you can have an idea about the commands that you can use. The very first command that is used is attach command. Attach, and within parentheses, the name of the data set. Like in this case, attach within parentheses, I am using pressure. Pressure is the name of the data set. So accordingly, it will allow you to draw your graph only after running this command. So first command that you will have to run in your R interface is to attach with that particular data set. And the second command that I'm using here is str command. So if you are not sure that what kind of variables are there in that data set or what kind of values it possesses, so you can first look into the structure of your data set. For that purpose, str command is being used. Str within brackets, you can specify again the name of the data set. And the third command, as you can see, so I hope now you can understand that this greater than sign is just the prompt in the R interface, after which you can write your R language commands. So the third command in continuity which is needed is plot command. At this instance, I am not using any additional argument, only it is telling that which attributes or which variables are to be used for plotting your graph. So I am opting for temperature versus pressure. You can note down one more command, that is data command. So if you want to look into the values of the different variables like temperature and pressure, so you can pass the command on the R prompt data and within parentheses the name of the data set. So as I said earlier, we are going to make use of pressure data set. So data within brackets, pressure means I can display after this the whole data that it is having. So you will have to pass the two commands in continuity, data within brackets pressure and then simply pressure. So after executing this command in the R console, you can have an idea about that how many observations it is already having, what kind of values it is having, and then you can proceed with the plotting of the graph. So this task is to be done before you plot the things. So you can first look into the structure of that, you can view the data, and then you can view the structure also, and then you can allow the R console to run the command plot, which will help you to draw the graph as per your need. So next thing comes is, can we save our plot also? So there are two methods for that. One is that from the R console, you can easily save your file. Go to the file menu and click on the save as option. As you save any other file on your system, in the similar manner, R console is allowing you to save your plot file using either PDF or .jpeg or any other format that you are interested in. You can opt for PNG file format also, .jpg file format also, .pdf also. So one more interesting thing over here is, can we do the same thing without going to the file menu? So there is the second method to save your plot, which is being written at the end. You can opt for the particular file type that you want to save, like I want to save it using the JPEG. So for that purpose, there is a function in our language. You can just look at the last bullet, which is displayed in this slide. JPEG within brackets, within double quotes, you write down name of the file. Let's say mygraph.jpg. Fine. So you will have to write this command in order to save your plot using the name mygraph.jpg. Similarly, you can save it as mygraph.pdf or mygraph.wmf or mygraph.png. These are the various file formats. Normally, we want to save our graph as an image file so that we can make use of this particular graph in some other report or in some other thesis file as an integrated component. So later on, you can make use of this graphical results. So in this kind of method, you need to run the three commands, which is written as method 1. It is the command way to save your file. So you will have to first specify which particular file format you want to choose, and then you plot the graph. Just look at the method 1, line 1 JPEG, mygraph.png or .jpg, whatsoever file format. But you will have to remember that outside also the name should be same. If I'm interested in saving it as .jpg, the name of the function should be JPEG. If it is a PNG file, you will have to change the name of the function PNG within brackets, double quotes में आप बताएंगे उसमें name of the file mygraph.png. Then plot the graph, let's say between temperature and pressure, and then dev.off. I have written DEV. Just look at the top. The cursor is not coming. Okay. So as we can see here, this command dev.off. So you will have to execute these three commands in sequence in order to save your file. So if you feel comfortable using all these commands, you can do it like this. So by default, it will save it in My Documents folder. Otherwise, you can simply opt for the R console file menu. Second method, that is comparatively easier for the beginners. So simply save your plot by going to file menu and then save as option, as you do it with other kind of file saving. So these are the two ways through which we can save the plot. So as I said earlier, in graphical analysis, while drawing any kind of plot, we do have many kind of needs. Let's say I want to emphasize something. I want to make certain changes in the display of the points in my graph, which are being represented either by some points or by a line graph. So these kind of things can be modified using the plot command arguments. So just look over here, what kind of things you can change. Type of a graph, I can modify it. Symbols of points, like in this particular image, you can see that the points are being displayed using circular red color points. Fine. So if you want to display, let's say in place of these red circles, you want to display it using star, or you want to put over here some other kind of symbol, let's say square, or some alphabet you want to display, let's say A or B. So these all kind of changes I can do in my graph. Then comes to size of points. So if you feel that these points which are displayed in the graph are small enough and you want to make bigger, so you can modify that also. You can make changes in the line type. Right now it is a solid filled line in your graph. If you want to show it as dotted line, you want to show it as dashed line, so all these kind of changes I can do. And then further, color of points and lines. You can modify color also. Rather than making use of red, if you don't feel that red is looking good, you can make the changes. So these all kind of color changes or font changes or look and feel of the graph can be modified using the plot command arguments. So in this slide, you can go through what kind of changes I can make in the type argument. So you need not to remember all this. Remember this thing. In R console, you're having help regarding all kind of commands. You just need to put question mark over there, question mark and then plot command. So it will show you all kind of help related to all attributes of plot command. So for your understanding, I have given certain type arguments, like you can put in type equals to P or type equals to L or type equals to B, H, S, N. Need not to cram all this. These are the various possibilities that we can use. So just look at the example given. I am using additional attribute type. It was not there in the earlier case. When I run first time the plot command, it was simply having two variable names, plot, temperature, comma, pressure. But I want to go ahead with certain changes. So I want to specify type equals to P. By default also, the graph is being displayed using points representation. So if you want to make certain changes, you can do. You can see the result of this as in this graph. So if you will run the earlier command, plot, temperature, comma, pressure, comma, type equals to within double quotes P. So P means I want to plot the points. I hope you are getting the difference between the earlier display and this one. It is only having points. There is no connected line in between. So how you will go about that? If you want to display a line also. So for that purpose, you can do type equals to L. L for line. If you are using type equals to P, it will only display points. If you are using type equals to B, B means points as well as line. And if you are using H, it will show you graph with vertical lines. So these are all the different possibilities which can be used using the type argument. So till now we have covered how to plot a simple graph by passing the required variables along the X and Y axis. So you will have to choose as per your requirement from the data set between which two variables you want to display the graph. And then you can use the another argument, that is type. Type equals to P or L or B. So default setting, you can see that type equals to P is default. If you will not give any type argument, it will display using points. It is default setting. Otherwise, you will have to use type equals to certain value. Now come to another kind of arguments that we can choose. Just look at this table at the bottom of this slide. What kind of different possibilities we do have. So you can see that if I will use PCH equals to 0, it will make use of this square symbol for plotting the points in the graph. If I will make use of 1, it will use diamond shape. For 5, if I am using PCH equals to 2, it will show triangle. Instead of using round circles in the plot of a graph, it will use triangle single. Similarly, you have different values. So how many values you can go ahead? PCH equals to 0 to 25. Different kind of symbols you can make use of for plotting your graph. So let's say we want to display star. So star is having a value in the table. PCH equals to 8, right? So you will have to use plot temperature comma pressure comma type equals to, if you want to give some type, and then comma PCH equals to 8. So here the command also is given in the particular pic. Plot temperature comma pressure, like type equals to B means it will use points also and line also for the display. As you can see in the graph also, it is showing you line connecting the different points in the graph plus the symbol that you are specifying. PCH equals to 11 means this a star symbol is there. So in this manner I can modify my graph using these attributes. So one by one you will see that there are lot many other options also that you can use. Then comes the next attribute in our collection of plot command arguments, that is font. Font is only used when we are using some character symbol. If we are using some character symbols, please note down, this is important. If you are not using any character symbols for plotting your different points in the graph, then this font will not work. It will only work if I am using some symbol equals to, let's say, A. All the points in my graph are being displayed as A. And for displaying A, I can make changes in its look. Font is being used for normal font or bold italic or simply italic. You can see one example in the next slide. Like here. In this we have used font equals to 4 value. If I will make use of font equals to 4, it will show you a graph like this. What kind of change it is showing? Rather than using a round symbol or using a square or star, it is using character as a point in your graph. A. And as I have specified font equals to 4, and 4 means just look at all these 4 points. If you are giving it a value font equals to 1 means a normal font. If I am using font equals to 2 means it will make it bold. A will be displayed as bold character. If I will use 3, it will show you italic. And if it is 4, then it will make it bold and italic. So the point to remember here is, if I am using this PCH equals to some character symbol, only then you will have to use here font equals to 1 or 2 or 3 or 4. Your choice. So it will pick only 4 values. Font equals to either 1 or 2 or 3 or 4. These are the 4 options for the font style, you can say. So next is CEX argument. CEX argument works for the size of the point that you are displaying. Like I have used the symbol A. So I have already seen that how to make the font style changes using the font argument. But if you want to increase the size of this A in your graph, so you can use CEX equals to 2 or 3, because if you will keep on increasing, it will show you your points so large in size. So that is not required actually. So put it either 1 is default, make it 1.5 or 2. So you can try this and then decide what value you want to give. So you can see the difference that if you will, I will make CEX is equal to 2, this argument will help in increasing the size of the points. Next comes LTY, line type. So in your graph, the important thing is by using which symbol you are displaying your points and how those points are connected in your graph. Earlier it was a solid line. So for solid line, you will have to use a argument LTY equals to 1 only. And 1 is by default, solid line. So you can make changes. You can make it 2, 2 for dashed line. You can make it 3, 3 for dotted line. Dash dot, it will be displayed using 4. And if you want bigger dash, the size of the dash is comparatively large. So in that particular case, you can use long dash. So there are two ways. You can specify the argument value either by specifying it using numerical value, 1, 2, 3, 4, 5 options, or you can also specify LTY equals to double quotes, and within double quotes you can write solid. So I have given one example at the end of this slide. So there are two ways to modify the line type, either LTY equals to 2, that is numeric way to assign the value to this argument, or you can specify it using the name of that particular line type, like dashed or dotted or long dash. So it is always given in double quotes. You will have to make use of this. As and when you are assigning some value that is character string, you will have to assign using double quotes. If it is a simply numeric value, whether it is font or it is CEX argument or it is a type argument, you can always go ahead simply type equals to 1, CEX equals to 2. You need not to make use of double quotes. Then comes color. So color is an important argument which will help you in giving a color to the line or to the font or to other elements of your graph. So if you want to see how many colors are available in R, so in R console you can simply pass this command colors, COLORS, and simply parenthesis as you write a name of the function. So this colors function will allow you to see all the list of colors. And if you are interested in giving it using some numeric value, color equals to, let's say, 2. So what it will do, color equals to 2 means it will show you red color. If it is equals to 4, 4 means blue color. Or I can write the name of the color, COL equals to, within double quotes, blue. So these are the two ways through which you can assign the color to any specific points and lines. So you can note down the example for this. Plot temperature, comma pressure, type equals to, let's say, B. B means line as well as points, and COL equals to red. COL equals to red means it will display your points and lines in this particular color. Then comes line width. So you can also specify that along with line type, that is LTY argument, you can also use LWD argument, which is used for displaying the particular line in your graph with a varying width. In this example, I am using LWD equals to 2, so it will enhance the width of the line displayed. So for increasing the thickness of line and points, you can make use of this attribute. And just for revision's sake, till now we have done various kind of attributes testing. So you can just go through quickly. The first example, simply temperature, comma pressure, type equals to P for making the graph with points. If I'm using type equals to L for making the graph with lines. If I'm using type equals to B, B means graph with both lines and points. PCH, another argument I told you, it is having values between 0 to 25. So either you write PCH equal to 5 or 2 or 3, or you can display the name of the character that you want to display within double quotes. So it is having all those examples here displayed. And font attribute only works with the symbol which is character. Font equals to 4 means if I am using PCH attribute equals to A, character display of the points in your graph, then only font will work with this. So these are also for your quick revision. We have used another argument as CEX. CEX was for increasing the size of the points in your graph. And then we have done with properties of lines, that is LTY, line type, and we have done it for line width, LWD. And another argument that we have covered for changing the color of points and lines in your graph is your color argument. So these are certain basic things or basic arguments that we can use in the plot command. Now comes another set of elements that we can modify in our graphical analysis, that is title and subtitle of a graph. So till now we are simply talking about how you can go about creating a simple graph. We are not proceeding to pie chart or histogram or bar plot and so on. So these are all simply about when we are plotting between two variables along x-axis and y-axis, and how we can change the properties of different graph. So on the whole, in title and subtitle also, you can modify three kind of things. You can modify the color, you can modify the size, you can modify the font. Font always means font style: normal, bold, italic and bold italic. So as I have done it with respect to different symbols, I can also do it for my title of the graph and subtitle of the graph. So in the first case, first we will cover how to add the title of a graph. And for that purpose, we are having an argument as it is written here in the plot command, main, M-A-I-N. Main is the argument in the plot command in our language, which allows you to give your main title to the graph, which is always displayed at the top. As in this case, I am choosing the title of a graph as pressure versus temperature. So by using this argument in the plot command, plot temperature comma pressure comma main equals to, within double quotes you write down the particular title of graph. So it will be displayed at the top of your graph when you will execute the same command in R console. And then come to color, font, and what was the third one? Size. Fine. So one interesting thing here is rest of the things will remain same. Only I am making certain changes like col.main. Just look at this command. col.main equals to 3. So what does it signifies? It signifies that I am going to change the color, but about what? I am going to change the color of the title of my graph. So for that purpose, I will have to make use of col.main equals to any numeric value. And if you want to specify any particular color, then within double quotes, red or blue or green or sky blue, you can see the whole lot of color list in R console. By passing the command again, colors. Colors command will help you in seeing the list of colors. So these are the two ways. Either you simply make use of numeric value, and if you want to give certain specific color, then you can specify the name of the color within double quotes. Character string will always come within double quotes. If you're not giving it, it will show you an error message. And then comes next thing that we are going to do is size. Size of the title. So if you're not convinced with the size of the title, you can use cex.main equals to 2 or 3 as you feel okay for your graphical display. So that will help you in enhancing the size of the title. So the complete command is written above. Plot temperature comma pressure comma main equals to the complete title CEX dot main. Don't forget to use this dot main. Otherwise, it will not understand to which element of your graph you are going to make the changes. So CEX dot main will help you in deciding that you are interested in changing the size of the title. So similarly, what was the third element? The third element that I want to modify is the font style. So my title is pressure versus temperature. I have modified the size to 2 or 3, and I want to, let's say, I want to show it as italic style. So I will have to use font dot main equals to 3. And if it is bold italic, it will come as font dot main equals to 4. So in this manner, we can apply color, size, and font, these 3 properties to the title of your graph. And similarly, if you want to apply it to subtitle which we always display at the bottom of the graph. So for that purpose, there is another argument in your plot command, and it is SUB. Write down SUB equals to, within double quotes, you can specify any subtitle for your graph. Vapor pressure of, one word is missing here in the slide, vapor pressure of mercury as a function of temperature. It can be any subtitle depending upon the data set which you are using for displaying your graph. So in this manner, I can modify again the color, size, and font of subtitle also using sub dot, color dot sub, CEX dot sub, and font dot sub. The only change will be the preceded word. Rather than using color dot main, CEX dot main, what I will do, I will make use of again for changing the color of the subtitle as COL dot sub equals to 4. So it will make use of the color 4, which is in the list. I think it's blue. So it will show you the subtitle of your graph in blue color. Similarly, subtitle. So you should always remember that the main title should be displayed in the higher size. And if you have already opted, let's say CEX dot main equals to 3. So your subtitle should be lesser than that in size. So that's why it can also be given in points, 1.5 like, or it can be whole number 1 or 2. But not more than that. It will not look good in your graph if you are going to choose your size of the subtitle as 4 or 5. It will show you in quite bigger size. So always choose it comparative to your main title. And last one, that is font dot sub. So you can write parallelly both these things. For main title, we are having main argument, and for the subtitle, we are having sub argument. And then we can make the changes in their font, size, and color. These 3 things we have covered with respect to subtitle and main title. So this is all what we have done in this section. How we can change color of title using COL.main, any numeric value, then size of title, CEX.main, then font of title, font.main, similarly for subtitle. So it's a quick summary. Those who want to just recheck the things that we have done with respect to changing the title and subtitle of your graph, you can just have a look on these all commands. So for your help purpose, I have given as a summary at the end of this. Then another section that we can modify here is modifying the axis of a graph. If you remember in your application softwares like Excel, it's a job of just a few seconds. Always in your graphical interface, you just go about putting certain values in the graphical interface. You click on OK, and it will apply the same to the given graph on the screen. But in our language, it's not like this. You can see that using the plot command, we will have to give each and everything using a particular argument with its value. Only then it will apply. Otherwise, what it will do, whatsoever default values are being set, that will be applied to your graph. So next section is how we can change the properties of axis of a graph. So normally when you're displaying your graph between x and y axis, so I do have axis value and certain labels which I'm interested in. So similarly I can make changes to the axis labels. I can give it accordingly, otherwise by default it show you as x-axis or y-axis. If you want to give any name, like in this particular graphical plot, the x-axis label is age in years, and on the other hand along y-axis what it is showing you, weight in kg. If you are not going to give it in the plot command, it will choose by default. So you can make changes in the axis labels, and the values displayed along axes are 5, 7, 9, 11, 13, 15. So these are all the axis values. Similarly, along y-axis we are having 15, 30, 45 and 60. But if you want to change its properties, you can do it using arguments that we are going to discuss in next few minutes. So let's see the first thing, how we can add the labels first, x label and y label. So which label rather than a default one you want to add? Like in this case, I am saying plot temperature, comma pressure, comma x label. X LAB is the argument. Similarly, y LAB is the argument, and then give required x label and y label. And remember again, it is to be in double quotes. Only within double quotes it will accept the text string. So you can give your graph x-axis and y-axis labels using the command. Then comes to again the color of this particular label. So if you want to apply a particular color to your labels, like in this case it's showing you in violet color or somewhat similar to that, so you can put the value COL.LAB. So it's very easy to remember also, and if you forget the name of the argument, you can just look into the help of plot command and its arguments. So earlier what we have done, col.main means we are going to change the color of main title. col.sub means we are going to change the color of the subtitle. And col.lab means I am looking for changing the color of the labels. Not specifically x or y, it will apply the same color to x label and y label. Next comes to size of the labels. So if you want to modify, like in this case, I have increased the size of the x and y labels comparative to the earlier display. So for that again, cex.lab. So it will modify the size of the labels displayed on your x and y axis. And then comes the font style, font font.lab. So you can see that it is applying the same kind of argument. The only difference is it is followed by .lab, that is label. So accordingly it will apply. So in this manner you can make changes in the labels of your axis. And then comes limits. It is a very essential part of your graphical display of graphs. Normally, if we are not specifying any limits for x-axis and y-axis, it will do it by default. So if we are interested in giving x-axis limits and y-axis limits as per our own choice, so we will have to specify it using a numeric vector array. So, sir, can you give me an idea whether you have done how to specify numeric vector array? Because in this course our sessions are very less and it's difficult to cover all the essential basics of R in a single session. But for your convenience, I have added one example in the slide. You can note down this. So what we have done, plot temperature comma pressure and xlim. It is for x limits. means I am going to specify certain limits for the x-axis values, right? That is displayed along the labels. So x limit equals to c within brackets 150 comma 300. So what it is telling? It is telling to the plot command that along x-axis whatsoever x-axis values I am going to consider, the minimum is 150, it will go up to 300. And similarly I can specify the y limits equal to c within brackets 0 comma 200. So it will initially use 0 and it will go up to 200 along the x-axis. So in this manner you can specify this equal to c means it is the syntax for defining your numeric vector. And I am using only two values, the starting value and the ending value. So I will assign this particular limits to the y limit and above to the x limit. So you can make changes in this syntax. X limit equals to c within brackets you give the lower value and the highest value. So in this manner you can set the lower limit and the upper limit for your x-axis and y-axis. Then comes color of axis values. So in this case col dot axis, you can see that all the values that are displayed are right now in cyan color. So this can be done using the col attribute again dot axis. So all the axis values will be displayed using this particular color. Earlier we have done it for labels, axis labels. Right now it is applying the color to the axis values. So default is black. If you want to make changes you can do. And similarly size cex dot axis. When you are writing cex dot axis means axis values, and when you are writing cex dot lab means for labels, x-axis label and y-axis label. And similarly font dot axis. So till now what we have done it for main title, all these property changes we have done it for subtitle, we have done it for labels, and we have done it for axis values. So in this manner we have learned that plot command is having lot of possibilities for modifying your graph, particularly on the screen. Then I am going to give you certain another data set idea. So there is one more data set we are going to make use of, that is iris data set. Iris data set is one of the very popular data set that the researchers are using for doing their data mining task and for graphical analysis. It is a flower data set which is having different type of species for this particular flower, like Virginica setosa and so on, and it is having different attributes like sepal length or sepal width and so on. So what you can do before you plot a graph, just see its structure. Again the method is same, str within brackets name of the data set. So if you know the name of any data set, that is either preloaded in R or you are going to use it. So always see its structure. str within brackets name of the data set. And then followed by the command attach within brackets name of the data set. Without using attach command you cannot display. So it should be used once before running the plot command. And sometimes the key point to remember here is sometimes it doesn't work smoothly. So you can just close your R console and you can open it again and you can rerun the same commands if it is showing some error. Next come to how we can display certain additional things along x-axis and y-axis. Sometimes we want to signify certain important points, like along the temperature axis I want to show some temperature is low. I want to put label over there low, medium and high. And similarly we want to show certain labels along the y-axis. So for that purpose you can change the axis values using the axis command. AXIX command, and it makes use of additional arguments. The first argument is side. So you will have to tell on which side of your graph. If it is 1, 1 means bottom. If it is 2, 2 means on the left hand side you want to display, and 3 means top side, and 4 means right side. So the first argument simply is side, and second one is at argument. At which specific X or Y axis values you want to show a particular label. If say the temperature is simply, let's say 10, 20, 30, 40, 50, and at a 10 temperature I want to show a label low, and at another temperature, let's say 30, I want to show medium, and at let's say 45 or 50 I want to say high temperature. So this kind of assigning of labels along the axis can be done using the axis command. So just see in this graphical display what it is showing. On the x-axis it is showing you low, medium, high. So how it is done? After the plot command you can run the axis command. It is separate from this. So in this particular case, I am plotting the graph between two attributes of iris dataset, sepal.length and sepal.width. So the plot is between sepal.length and sepal.width, and x is equal to f. Note down this new change in this function. X is equals to f means, are you seeing any axis here? Is there an axis? X-axis, Y-axis, where it is? It is not available. Equal to f means it will not show, it is only showing the plotted points. So x is equals to f means it will discard the x-axis and y-axis, only showing the points plotted. And I have added additional axis here at the bottom, which is having 3 labels, low, medium and high. But at which point it will show you? So it is showing you that sepal.length is along x-axis, sepal.width is along y-axis, and along x-axis there are certain points whose values are 4.5, 6 and 7.5. Just see here in this command, at attribute. Side is 1 means bottom of the graph, comma, at equals to C, and within brackets I am specifying certain values. The first value is 4.5, the second value is 6, and the third value is 7.5. It means out of the available x-axis values, it will choose these specific sepal length values, and there it will display what labels? So the third attribute here in labels equals to C, within brackets the first value is low, comma, the second value is medium, comma, the third value is high. So how it will correlate between two? At point 4.5 along x-axis it will show low. At a particular x-axis value 6 it will show medium. At a particular value 7.5 it will designate it with label high. So in this manner sometimes we do have certain specific requirements while plotting the graph. So there is an axis command for that, and it is using 3 arguments. The first one is side, the second one is at, and the third one is labels. So you can apply it to x-axis along or y-axis, both ways. If you want to display the same thing along y-axis, then side equals to 2. Side equals to 2. Just see here. I have added axis. The first argument is 2. The side of the graph. The bottom of the graph is chosen as 1. Left hand side is 2. The top of the graph is 3. And on the right hand side is 4. So side means at which side of your graph you want to display the axis. And at means at which specific points you want to designate it with label. Fine. So side equals to 2 means I want to display this labeling along y-axis. Fine. Then comes box. Sometimes you need to draw a box around your plotting. So for that there is a box command, box function. So this box command will be run to draw a particular square around the plotting. So just remember one point. Plot command is run first, axis command is run, and then at the last I am drawing the box. After plotting the graph, it is followed by box command. So sometimes we do mistake, a very silly mistake, that we run box command first and we are looking where it is. Nothing is coming. So first you plot the things, add the axis, and then you bound it with rectangular box. So that will be done using the box command. So this is a summary for you, what the things that we have applied to the axis of graph. So we have done it for axis labels. You can see how to add X label and Y label command argument. Then we have done the color of axis label, and it was done using the col.leb argument. And then size, it was done using cex.lab, and the last one, that is font.lab. And similarly, we have modified the X limits and Y limits, and then we have followed by the color of axis values, size of axis values, font of axis values, and axis values for labeling the X or Y axis. So this is all what we have done in this section regarding modifying the axis of a graph. So dear participants, till now we have seen that when we are handling with certain simple graph, so we can certainly modify its properties. And you have seen that it's not that easy as we normally do it along with any application software. So on the similar pattern, we are having certain other elements that we can add upon. And in this category, we are having how to add a legend on a particular graph. So I am going to take the same example of the iris data set that we have just used for drawing a plot between the sepal.length attribute and sepal.width. And there is one more additional attribute in this data set which is named as species. So if any one of you understand that in data mining we classify our data using a class or a label attribute. So in this iris data set, there is one last attribute which is named as species. So species is telling with respect to every record in your data set that a particular flower having certain properties is named as Setosa variety. Similarly, a particular record labeled with species versicolor and virginica. So in this section, we will see that if we are having such kind of classification available in our data set, so how we can go about drawing a legend or adding a legend on our graph so that we can show that the different points that is being plotted by us in the graph are of different categories. So for that, there is a command in our language. It is known as legend command. So just see here in this example what we have done. The command for plotting the graph will remain same, plot command, and in this we are using sepal.length. You can note down this example in order to understand what we are going to do. Sepal.length, the first attribute from the iris data set along x-axis, and within square brackets I have chosen species equals to, double equal to sign is here, species equals to Setosa, means while plotting certain points in my graph, I am specifying a condition that only plot the sepal.length attribute value if the category for flower is Setosa. Then followed by next argument, PCH equals to 3. So you can plot a particular point using a particular symbol. Then line width equals to 2. Color for plotting the points and lines is 2. This all we have done in the earlier slides. So I'm simply using all those attributes. The new attribute that we are using is this one. How to specify condition. Y label equals to sepal length, sepal dot length, and y limit equals to c. And it is using one interesting feature here, that is I am using that the limits along my y-axis are having minimum out of sepal dot length attribute. So min is a function. If you are having any attribute in your data set like sepal dot length, it is having certain set of values. So out of those values, a value which is minimum will become my minimum lower limit for the y-axis. Similarly, max function tells you the maximum out of numeric values. So I am interested in choosing y-axis limits as minimum out of sepal dot length. So I am using here a function. If you remember the earlier slide, we have given x limit and y limit. There I have specified the static values like x limit equals to c within brackets 150 comma 300. I have done it earlier. But right now I am saying not a static value, but it will find out using a function minimum out of sepal dot length attribute. And similarly, what will be the upper limit for y-axis? Maximum out of what? The attribute values which are being displayed along the y-axis. It is sepal dot length. So maximum out of that is your upper limit. So after plotting a simple plot like this, so it will show you these points with red color. The effect of running the earlier command which I have just shown, this complete command, it will show you a display like this. So you can just see for a moment what it has done. Sepal dot length is along the y-axis, and the values that we have chosen, the lower limit is showing 4.5. So it might be the lower limit for the sepal dot length attribute values in your data set. And similarly, the highest value it has chosen. So it will show you all the points. So you can note down one important point why I have selected the limits for this. Any point beyond these limits will not be displayed in your graph for sepal dot length, and variety is setosa. In my overall records, I am having different variety of colors, setosa, virginica, and so on, 3-4 different varieties. But right now I am interested in plotting only the setosa variety, which is being written here. Sepal dot length, species equals to setosa. I have restricted me, repeat the thing, the previous point that we have done. So I was showing you this plot, which we have just created with respect to a particular species of flower, that is setosa. So all these red point symbols are representing this particular variety. Then there is a provision to add on the points in my plot, and for that we are using next command, that is points. Points command is there, and point command is again using certain attributes. So what we have done, points within bracket sepal dot length square bracket. Square brackets are being used for specifying the condition. I am specifying a particular condition on an attribute. Sepal dot length is one attribute in your data set. I want to specify certain condition, and condition is species of that particular record should be only versicolor. If not, it will not show you in the plot. So this time I want to add on some new points with the color green, and the variety is species equals to versicolor. PCH equals to 8, again a particular symbol. As you can see that earlier it was showing you plus plus symbol. This time it is using some star symbol or asterisk symbol, and then color equals to 3. It is using green color. So just in order to make a difference from the earlier points. So remember one thing, that once you have run the earlier plot command for showing the initial points of your plot, then you will have to follow it by using the points command. You can see in the display there are 3 commands. First command is plot. Second command is points. Then one more command. These all commands we have run on our console. Point command helps you in adding the points. Are you getting my point? Plot command is to draw the basic plot, and then if you have certain more points to add on in that plot, you can add them using the points command. So it is just a kind of adding points with some condition. So I have added some new points for the species versicolor. I have added some more points with the species virginica. So on the whole, what I will get after running all this kind of plot. So you can see that there are certain points which are red in color, symbol is different. There are certain points which are green in color with some different symbols. And thirdly, we are having this star symbol. So all are representing different varieties of flower. Fine. So now comes the need of legend. How to represent, what kind of points they are. So I need to add a legend. And here comes the command in our legend command, and it is having different arguments. The first is location. The second is a particular legend that you want to draw, and PCH attribute, LTY and COL. These are earlier ones. So you do it using example that will help you more. Like in this, one example is given. So just try to understand what we have done. Legend within parenthesis, top right. Top right means I am interested in telling the location. Location argument is taking the value top right. Again, remember, as it is a character string, within double quotes you write it. Comma, legend equals to. Normally in a legend table, as you were asking me, in a legend table you will have to specify the different types or the different classifications. So in this particular case, what kind of classification I am having? Some flower varieties. So all the flower varieties that I want to designate in the legend as an information, I will write down as a character array. This is known as character array. Legend equals to C. Earlier in previous slides, we have used some numeric values. But right now I am having some flower varieties. So all the names will come in double quotes. Setosa, comma, versicolor, comma, virginica. If let's say these are the name of persons, Ram, comma, Mohan, comma, Sham, anything you want to write. Numerical value is always simply without quotes separated by comma. If it is a character array, all the values should be in double quotes separated by comma. Then PCH equals to, again, see what I'm using, it is a way to represent numerics. So it is associating that Setosa using a particular symbol. Symbol was plus. Next variety is versicolor. I am saying 3, 8. So means 8 is corresponding to versicolor. Using only the single argument PCH, but right now it is having 3 values. 3, 8, 11. So how it is using? It is using a particular symbol with numeric value 3 for Setosa. It is using 8 as a symbol. 8 के corresponding जो भी आपका symbol था list में वो use करेगा versicolor के लिए. Then thirdly 11 के corresponding जो symbol है वो आपका जो star वाला आ रहा है ऊपर blue color में वो virginica के लिए. इसी तरीके से कलर बता दिया हमने कि जितने भी मेरे डिफरेंट कैटेगरीज हैं ग्राफ में, उसमें पहली जो आपकी कैटेगरी है सेटोसा, उसके लिए कलर लिया है 2 वाज रेड. वर्सिकुलर के लिए मैंने लिया 3 वाज ग्रीन, और वर्जिनिका के लिए 4. So using numeric and character array, it becomes so easy. Otherwise, you will have to tell explicitly separately. So that is a tougher job. In this manner, within a single numeric character and character array, you can simply tell for which category, which color is used, which symbol is used. So the task is quite simple. And how to run this command? After plot command. I don't know whether it is visible or not. Otherwise, you just read the command that is given in the slide, legend command. Just like points command, it is to be followed after plot command. It's not a part of within plot. After running the basic plot command, you add on the legend on that. I'm adding on certain points using the point command. We are adding legend on that using legend command. If you are adding a axis command, fine. So what is this? This is adding additional elements to your graph. I have already created a basic graph, but I am interested in adding legend, some axis values, some other elements. So you can go about using legend. So just see what it will do. The location is top right corner. The name of the legend classification is Setosa, versicolor and virginica. Just look at the labels along Setosa plus along with versicolor asterisk mark, along with virginica star. So in this manner you can add on legend in your graph in our language. So it's a quick summary for you. Just check it out what we have done. Basic command that we have run covering all the basic argument values. Then we have added some more points for the versicolor variety using points command. Then we have added some more points on that plot for the virginica variety. And then we have added at the end legend. So always remember that legend is a requirement when in my graph I am having some different set of plottings. If all points are of the same color, you may not be needing the legend. But if you have different category of data, in the single data set, the data is categorized among different classes. Fine. In that case, we need a legend in order to understand our plotting. And then comes the requirement of some special graphs like pie chart, bar diagram, or histodiagram. So as long as the time will permit me, I am left with 15, or we can extend it to 5-7 minutes more. So in that, I will give you a quick review of some type of plots. So till now, we have simply plotted a main basic graph and we have modified all the properties. So let's see how pie chart can be drawn. So in pie chart, again, you will be needing a data set. So this time I am using empty cars. Note down, empty cars is one of the, again, a data set. I'm going to draw a pie chart by taking data from the empty cars data set available in R language that is preloaded. Fine. str command is used for seeing the structure. So just look on the side display. It is showing you all the different variables. So on the total, it is having 32 observations and 11 numeric variables. Observation means different records. And 11 numeric variable means I am having different 11 variables in each single record, corresponding to which you are having value. So just like a two-dimensional matrix, you are having 32 observation and in every observation you are having 11 values corresponding to different 11 numerical variables. So str command allows you to see the different variables, their data types and their corresponding values further if you are interested in. So just note this command mtr and this less than sign hyphen. Sir, any idea about this, what we are doing? Just like in other programming languages, empty is a variable in which I want to assign some set of records out of empty cars. So let's say empty cars is having 100 records. Empty cars is a data set having 100 records, right? If somebody says, okay, extract the top 5-6 records. So in that case, our language having a command head command. Head within brackets name of the data set. What it will do? It will extract the top records. Limit is inbuilt fixed. 6-7 records it will pick up from the top. Head means upper records, right? And after picking the upper records, what I will do? I will have to save it somewhere. Just like other programming languages, you do x equals to 5. Fine. Name equals to, what's your good name? Avinash. Name equals to double quotes Avinash. So similar to that, if you want to save set of records somewhere, so what you need? You need a data frame. We call it data frame. In our language, this data structure is data frame. So I am going to assign the top 6 records extracted from where? Empty cars data set, and I will assign it to empty variable. Fine. So just see in the display. In the earlier command, I have taken the top 6 records from empty cars data and I have assigned. It's not equal to sign. R language mein, if you want to assign this less than and hyphen, arrow, just like an arrow mark. So what it is doing, it is extracting the top records using the head function and it is assigning to the variable empty. Why I am doing all this task? I am doing it in order to draw a pie chart, and for drawing a pie chart, I need certain records. So rather than doing it for all set of records, I am extracting the top records from the data set and I am saving it to empty variables. Then you can view what empty variable is holding. So empty variable is holding this matrix type data, right? So this on the right hand side, left hand side, you are having the list of all the car varieties, and on the column side above it is having all the variables names. So corresponding to a particular car, let's say it is a Maruti Suzuki, it's a Honda City, it's a Brezza, or it is some other car. So on this side the name of the car is coming along the row number, right? And on the column side it is showing you different attributes for which it is having a value. So in this manner, empty cars data set is having 11 numerical variables, and out of that I have just picked up observations which are the top 6. And now I will draw a pie chart of this. So just remember, my data is saved in which variable? Empty variable. And empty is holding what? The top 6 records. From which data set? Empty cars. Fine. So unless until you are not having reference to which data you are going to use, it will not draw the pie chart for you. Fine. Attach empty. So I'm not going to attach the complete empty cars, but I'm going to attach empty. This data frame, which is holding these 6 records. Pi within brackets disp. So disp is what? Disp is one of the numeric variable in my empty variable. Disp is not the all. Out of the 6 records, each record is having data for 11 variables. Out of that I have picked the one. DISP, I have picked the one variable, and for all the corresponding 6 records, I will draw a pie chart for this variable. Again, go back and just see what it is showing. It is showing certain name of the cars. And for each car, it is showing data for 11 variables. Out of these 11 variables, I have picked one, the third one. I don't know whether it is visible to you or not. First one is MPG, mileage, CYL, and the third one is DISP. So I have extracted this one. I want to plot a pie chart for this particular third variable named as DISP. It can be anything. Like you are having an employee record. Name of the person, age of the person, city of the person, designation of the person, salary of the person. And if I say draw a pie chart for salary of the person, so you will have to specify the name of the variable. I have attached empty. I have drawn the pie chart for the specific variable DISP. Fine. What is the difference in earlier plot and this? 1, 2, 3, 4, 5, 6. See around the circumference of the pie chart. So it is showing you the pie chart corresponding to the disp variable, but as I have not given any label, it has picked 1, 2, 3, 4, 5, 6. If you want to give specific names, labels equals to row name. So the first observation which was corresponding to a particular car, I will pick its name, its row name. So what it was? Datsun, and one is Mazda, another one is Valiant, and so on. So these are the different names for each individual observation, taken as row name, you can say. Fine. So it has taken name from there itself, from the data set, and it has assigned around the different sectors of your pie chart. Earlier it was default 1, 2, 3, 4, 5, 6. So I was not able to understand this pink color is for which. So I will look into my data set. Okay, let's go back and see. The row number 3, Datsun, and for this, it is using a pink color sector. Now my task has become easier by using this additional labels command. Labels equals to, from where it will take the labels? From the data set. Row names for each observation. So in this manner, for drawing a pie chart, as you can see that, there is a simple pie command. It's not tough. Pie within bracket आप बता दीजिए कौन से वेरिएबल का पाई चार्ट बनाना है. लेकिन मेन काम क्या किया हमने पहले डाटा कैसे एक्सट्रैक्ट किया ना. Fine. So we have extracted our data from the data set empty cards, the top 6 observations, and I have assigned it to empty variable, and that I have attach empty, and then I have drawn the pie chart with the labels corresponding to each row in my data set. So it is easier for me to now understand the pie chart. Similarly, we are having bar diagram, which is of different types. All of you who are doing your analysis work, they might be knowing. You can draw a simple bar diagram, you can draw a stacked bar diagram, or you can draw a grouped bar diagram. So with respect to R, I need to know how to draw. So for that, we are having a bar plot command. For pie chart, there is a pie command. For the time being, as the time is short, you can note the name of the function in R language. So pie command is for drawing pie chart. Bar plot command is used for bar plot. Hist command, H-I-S-T, for drawing the histogram. H-I-S-T, hist, histogram. So as you can see, in the journal syntax of this bar plot, I am having one argument is X, which is a vector or a matrix. Means bar plot will be drawn for a vector data or for a matrix form data. Analysis is only useful when you understand your data. And for your data, what kind of graphical analysis is needed. If your data is not suitable for drawing a bar plot, it will not draw. Similarly for pie and another kind of graphs. So X should be either vector data or a matrix form. Then comes horiz, H-O-R-I-Z. It is just for displaying my bars horizontally or vertically. You can change the side. It can be set to true if you want to display your all bars horizontal direction. And if you want to show them just like default vertical, you can leave this. Right? Means in our language kind of thing, you need to convey each and everything which you require through a attribute or an argument in the function. And the third one is beside. So that we will see how it will use one example. Right? So just if you will type the command bar plot within parentheses, I am saying VA deaths, square bracket, comma, 1, square bracket close, parenthesis close. So here I am using another data set which is VA deaths. Fine. So it is making use of data set VA deaths. And I am interested in plotting a bar plot. I am going to take all the rows in that data set, but only column number 1. My problem here in this session is you people are, I think, are not aware of all the basics of R language. R language is having different kind of data structures unless until you are not using those, like arrays. I'm having lists, I'm having data frames. So in the earlier example, I have shown you how to create your data frame. Data frame is just like a record sort of thing, a structure sort of thing. Similarly, you do have list, like say I say prepare a list of employees and I want to save the information of each employee's name and child's and their salary and all. So you can create arrays, numeric and character, whatsoever is requirement. You can create lists, and you can create structures. Structure just like collection of records. So for that purpose, you will have to go through arrays, lists, and data frames in R language. Fine. So in this example, I am using a VA deaths is again a data set. And from that data set, I am going to make use of column number 1. Rest of the columns, I will leave. So it will draw a bar plot for that. Because I said bar plot can be drawn for vector type data and for matrix type data. Fine. So in VA deaths data set, the column number 1 is having different values for that, and it has shown you the bar plot. The command is simple bar plot, but it is making use of a particular data set, and from that data set, the column number 1. Before comma, you can see that I have not written anything. So what does this means? If you are having 100 records, so it will pick all the 100 records, and in every record it is having 10 values or 10 column values. It is only picking the first column value. So just think in terms of 2-dimensional matrix. I am picking all the rows, but I am picking only the first column. All rows, first column values are used for drawing the bar plot. Getting the point? So this manner, horizontal equals to true. So it will just change the direction of your bars. Fine. Bar plot, simply within brackets VA deaths. So what is the change? Have you noticed? What is missing now in this command? Bar plot within brackets, name of the data set. Syntactically, what is missing? I am taking all the columns. It is another kind of stacked bar graph. Earlier, I was using only the column 1 value. I am not showing here only column 1, but I have taken, let's say there were 5 columns. So it is taking all the 5 column values in each row of the data set. So for that, you can draw a bar plot which is of the type stacked bar graph. Let me go back. It was earlier command. It is for showing corresponding to a single column. Now I am using, let's say 4 or 5 columns for plotting my graph. So the type of the bar plot will vary. It is a stacked bar graph. You can see that different colors are used on grayscale, black and light gray, and that much lighter gray, and so on. Beside equal to true, the third argument, which I'm disclosing right now. So what is the difference in plot? Beside equal to t means true. All the 5 stacked bars are now beside each other. Rather than one above another, they are beside. So if beside is equal to true, it will display it like this. If beside equals to false, by default, it will show it like this. Getting my point? VA dash bar plot, VA dash beside equal to true, main equals to, main means title of the graph, color equals to 1 colon 5. Just note this syntax. Color equal to C within parenthesis 1 colon 5. 1 से 5 तक कलर की वैल्यू ले लेगा जो डिफरेंट बार्स हैं. फाइन. फर्दर तो हमने किया ही है, पीछे लीजेंड ऐड करना है तो लीजेंड इक्वल्स टू ट्रू कर दो. देखिए इसमें हमने क्रिएट नहीं किया, सिर्फ लीजेंड इक्वल टू ट्रू कर दिया. उसको ऑटोमेटिकली पता है बार ग्राफ के अंदर मोर देन 1 हमारे इसमें. ठीक है. हिस्टोग्राम आपका लास्ट जो है इसमें ये जैसे हमने एक रिवर्स डाटा सेट है उसके ऊपर किया, उसका स्ट्रक्चर देख लिया आपने. ठीक है. हिस्ट कमांड नोट कर लीजिए, बस हिस्ट कमांड है जो आपकी, जिससे आप ड्रॉ कर सकते हो. ये हिस्टोग्राम आपका ड्रॉ हो गया. हिस्ट विद इन ब्रैकेट नेम ऑफ द डाटा सेट. histograms with frequency are not comparable, especially when they are created with unequal number of observations. So in that case, histogram with density is applicable, which can be obtained by setting the argument frequency equals to 4. So if you are having unequal number of frequency, so in that case, you can make this frequency attribute equals to false. And breaks, you can specify the breakpoints in the histogram command. Frequency which is varying rapidly from 0 to 1500, and after that it remains almost same. So you can see that the width of the bars, is it same or varying? The last bar, which is having very short height, it is going up to 4000 last. So if some frequency is varying at different points and later on it remains same, so its width is more. So I have decided certain breakpoints. The first is 0, then 500, 0 to 500, 1 bar, 500 to 1000, second bar, then 1500, the third bar, and then last is 4000. So last bar in my histogram is going up to 4000. So in this manner, in hist command, we are having the first argument, name of the data set, the second argument was frequency, which you can keep true or false, and the third one is breaking points. So in this manner, we have gone through this. Fine.